Hey guys, today's video is about model evaluation. We've gone through k-fold, stratified k-fold, and leave-out cross-validation in the previous videos, so today we are going to talk about leave-1-out cross-validation. Leave-1-out is just a special case of leave-out, where p equals to 1. So let's review the concept of leave-out a little bit. Leave-out is an exhaustive technique. Each time p samples are used as testing set, the remaining samples are training set, and we have to iterate all the possibilities, which is the number of ways you can select p data points from n samples. In specific, the number is n choose p, and the exact formula is like this. Suppose n is 4, p is 2, then we have to repeat the validation process 6 times, which is equal to 4 choose 2. In fact, we'll calculate one model performance measure each time, such as accuracy. Then we take the average of these measures to present as model's final performance. Alright, now we can talk about leave-1-out cross-validation. There is nothing new, we just replace p with 1. Therefore, we use one sample as testing set each time, and the remaining n-1 samples as training set. This method is still exhaustive, because we again have to iterate all the possibilities, and choose one specifically. One thing to note is that you don't really need to calculate this number, since it's just n, the total number of data points. In other words, we want to make each data point as testing set once. So we start with the first data point, all the way to the last one, so we have to repeat the process n times. For example, we have this dataset with only 4 data points. I just want to remind you that this is a simplified case, that you don't get such small datasets in real life. We typically have thousands or tens of thousands of data points. Okay, so how many times should we repeat the validation? Yes, exactly. The answer is 4, which is the number of data points in a dataset. The pink block is the data point that is used as testing set. Then, as we said before, each time we'll calculate one accuracy, and the final accuracy is the average of these accuracies. Again, the evaluation measure doesn't have to be accuracy. We always use the accuracy as example just for the simplicity. Actually, the accuracy can only be 0 or 1 in this case. To illustrate, accuracy is the percentage of data that are correctly classified. Each time, we only use one data point as testing set. So the testing set is either 100% or 0% correctly classified. This could be a problem because we want our model to perform stably. I mean, although we take the average of all the accuracies, we don't want the model to perform perfectly sometimes, but pretty poor other times. This is kind of similar to a weakness of accuracy. Accuracy doesn't separate the data from different classes, so sometimes the model may only perform well in one class and get a high accuracy, which the model doesn't deserve. In this case, we are facing the same dilemma. When a model's performance fluctuates a lot, we can't be sure if this average number can represent the model's actual performance. Therefore, you should always think about this question when you use leave-1-out cross-validation technique. Alright, that's the basic idea of leave-1-out. Let's talk about its pros and cons. The first advantage is that the whole dataset is used for both training and testing. For a traditional validation method, testing set is never used for training, but the cross-validation method doesn't waste any of the data. The second advantage is that the evaluation result has low bias, because the size of training set is sufficient, which is n-1 explicitly. This is straightforward. We use one sample as testing set each time, so the remaining data can all be used in the training phase. However, leave-1-out method also has some problems. The first one is the high variability of the evaluation result between each iteration. As we said before, the accuracy can only be 0 or 1, and we cannot be sure if taking the average of all the accuracies is a faithful evaluation of model performance. Further, the computation time is high, even though n is typically smaller than n choose p, which is the number of iterations for leave-p-out cross-validation. N is still a large number. Suppose we have 500 data points, then we have to repeat the process 500 times. As a result, we only use leave-1-out when the dataset is small. Ideally, the training algorithm should be simple and fast. Otherwise, even for a small dataset, the validation process could be still time-consuming. Okay, let's end today's topic. Thank you for watching my video and see you soon.